Hi guys, I'm Whitney from Knitronics, and I'm here with a new video tutorial series teaching you how to get started with FPGA design, specifically in the Xilinx development tools. Now, this first video is just going to cover actually installing the Xilinx design tools, all the way from Vivado to Vitis to Linux. Now, the Xilinx installation has come a long way in the past few years in terms of ease of installation, particularly for Linux users like me. Today, I'm going to be running on an Ubuntu machine of 18.04.5 LTS. Let's take a look and start downloading. So if you Google Xilinx download, one of the first links you'll find is the Xilinx support download page here, like you can see. Now, the nice thing is it appears with the 2021.1 installation it's a full installer for everything, which is really exciting because a few years ago it used to be installing every piece individually. And with the same in years past, there's always 3 different options for the installer. There's 2 lightweight self-extracting installers, one for Windows and one for Linux. And then you have the unified full installer that is good for any OS that is supported by Xilinx, which is either Windows or Linux. So if you're going to choose between these 2, I recommend, if you have a really great stable internet connection, you're not planning on being interrupted at any point, the self-extracting web installers are great because they're just a small little file that actually pulls the download files from the server as you're installing them. However, if your internet connection is a little bit spotty, a little bit slow, or you maybe think you might get interrupted during the installation, I highly recommend going with this full installer download. As you can see, it's quite a bit bigger than the self-extracting web installers, simply because instead of downloading each piece from the server as you need it during installation, it's going to download everything it needs, meaning that you can then perform the installation later offline if need be. Since I'm on a fairly stable internet connection and I don't plan on getting interrupted, I'm going to go with the Linux self-extracting web installer for now. So I've already downloaded that in my downloads folder. So the first thing I need to do, just like with any other bin file in Linux, is make it executable. So I've got my command already here, so sudo chmod x, and then pointing out the bin file. So enter my password here. So now that file has been made executable. So now all we need to do is actually execute this bin file, which is our full installer. However, I did want to go back and mention something about specific system requirements, such as required memory, required disk space. Vivado has a design user guide, UG973, that will outline pretty much everything I'm talking about here, although I still think it's kind of helpful to actually see this happening. So starting in chapter 2 of 973, you'll see supported operating systems. Something I noticed interesting here, on Ubuntu support, it looks like it only goes up to 18.04.4. I have 18.04.5. However, I have installed Vivado 2020.2, 2019.2, all on 18.04.5. They've all claimed that they only go up to 18.04.4. I feel like this one should be okay. I did notice that the Linux separate user guide says it supports 18.04.5, so I'm kind of hoping this is maybe a typo. I'm not sure, but weird little things like this is part of the reason I'm making this tutorial series, so you can kind of work through some of this weirdness with me here. So looking down through the next chapter, supported devices, this is supported FPGA devices is what this was referring to. Of course, once we set up a project, we're gonna be running with the RDZ7 from Digilent, which is a Zinc-based device, which of course is supported. So for system requirements, it looks like they have memory requirements linked externally. So if I follow that, interesting. So it looks like each of the specific FPGA chipset families from Xilinx require different amounts of memory when you're generating bit streams or running synthesis. Well, hello, Moxie. If we're looking at the Zinc 7000, which is what our target is going to be, looks like typical is about 1 to 3 gigs of RAM to use, peak 5 gigs of RAM. Most computers, I assume, are gonna have at least 5 gigs of RAM these days. So let's take a look at the worst case scenario here. I guess that would probably be a Versal card, just to see absolute max memory that you could possibly need for Vivado. Looks like peak is 32 gigs. And, oh Moxie, you're really trying to help here. So let's take a look. It looks like the worst case scenario I'm thinking is 32 gigs of RAM. So let's just double check these other devices. Oh, I stand corrected. It looks like there's one of our Vertex UltraScale that could use 47 peak gigs of RAM. I doubt most of you watching this will be working with the Vertex series chips. Those are pretty intense chips. They're very expensive. They're mostly industrial application things. So I think the average user that's probably watching this video is going to be using either the Zinc 7000 series, the RTX chip, or the Zinc UltraScale Plus. So let's take a look at those. Looks like the Zinc UltraScale Plus, the worst case scenario it'll use is 21 gigs of RAM. You're pretty safe if you have 32 gigs of RAM. Probably 16 is all that you'll need if you're more of the getting started / hobbyist level. And especially looks like any RTX or Zinc 7000 chips, 16 gigs of RAM is plenty. I have 64 gigs of RAM in my particular machine, so I think we're good there. So looking through the rest of our system requirements, so cable installation requirements, that's not going to be applicable to us because we're not using a separate JTAG connector for a custom board. We're going to be using a dev board, so I'm going to skip over cable installation requirements. So the next section for licenses, typically if you're using a dev board from somewhere like Digilent or one of the more affordable option dev boards such as the Arty or the Zybo, there's two versions of the Arty, you typically don't need a license and Vivado is free. Vivado mostly only has licenses for their higher end cards or higher end IPs, but for now, we don't need a license for what we're doing and what we're compiling. Basic rule of thumb is if you need a license, the dev board you order will probably come with a license. We've got memory requirements covered, license requirements covered. Is starting in chapter 3 on UG973, it's gonna start walking through exactly how to install everything, showing you where to download the installer from, just like we did a little bit ago. So let's switch back over to our actual installer that we're about to run. Also, as far as free, Vivado is kind of a hard drive disk space hog. As you could see, the full OS installer is 51 gigs. So I recommend bare minimum having 52 gigs available on your machine. Rule of thumb, I typically like to have about 100 gigs of free space on my hard drive when I'm going to install a new version of Vivado, which I have about 400 gigs free. So anyway, so we've made our installer executable, and now we will simply run it with the following command. Checking integrity, all good. Uncompressing the installer, and success, the installer at least is up and running. Also, while I'm waiting for this to fully launch, there is, as far as library requirements on Linux machines, there is a link to an article here. I'll put it in the description down below, but there's a link to it in UG973, where the main thing that you'll have to prep a Linux system with is make the 32-bit architecture available, which you can do with your sudo dpackage add architecture i386. There's also the docnav that requires some 32-bit architecture, which docnav is the built-in documentation repository in the Xilinx tools. Very, very helpful. There's a few 32-bit libraries to install that are outlined here, so you can simply run sudo apt-get install for each of these. Looks like our installer has launched. It is warning me about being on an OS that's not officially supported, but like I said before, I've installed several versions of Vivado on 18.04.5. They seem to be running okay, so luckily this installer is going to go ahead and let us install. I think it was the 2020.1 package wouldn't let you install an unsupported OS at all, so I feel like from a Linux perspective, Ubuntu 18.04.4 and 18.04.5 are fairly minimal. The differences are fairly minimal, so let's go ahead. We're going to click next. So I've got my same Xilinx login that I used to download the web installer itself, and I'm going to select download and install now. So click next. So on the next page, the installer gives you a list of all the options you have to install using this installer. So something that's a little bit different with Vitis compared to when it used to just be Vivado and SDK as two separate programs, if you've previously used that, is that Vitis is technically the superset level install of everything. It's all encompassing. So Vitis includes the Vivado design tools as well as all of the embedded application development within itself. So we're going to select Vitis. We're not going to select this separate Vivado install because that would actually only install Vivado instead of Vitis as well. Looks like we don't need bootgen for now or lab edition. Those are just lower level, like stripped installs of specific tools within it. Will it let us install pet? Okay, so we'll have to rerun the installer to install Linux. That's okay. Let's get the main install done for now, which is Vitis with Vivado. We'll click next. So here on this next page, whatever you selected on the previous page, it's going to give you a list of everything that's being installed. So Vitis Unified Software Platform, which includes Vitis, Vivado, Vitis HLS, Model Composer, DocNav, and then the specific devices that you want to target. So by default, we have everything, the SoCs, the 7 series, so that's going to include all of your Xilinx 7000 chips, which is the RDZ7 that we're going to be using. That's all checked by default. The UltraScale Plus, which you'll want if you're using something like the Ultra 96 board. Versal ACAP, don't necessarily need that. I'll leave it checked for now. There's something called engineering sample devices for custom platforms. I don't really need that, so I'm gonna leave that unchecked for now to save space, but if I ever decided I needed that, I could just rerun this installer, check that, and it'll install it. This is talking about the cable drivers, so like I mentioned earlier, we don't need those, so it doesn't matter that it's grayed out. Next, agree, your typical read the terms and agree, click next, and I forgot I needed to run the installer as root, because the install path, the default install path is in my root folder under tools/Xilinx. Since I didn't run the installer as root, it doesn't have permissions to write that folder. So I'm going to click cancel. Yes, I want to cancel for now. Let's go back to my terminal. I'm gonna rerun, except this time sudo download/Xilinx Unified 2021.1. Let's try this again. Every time, I can't tell you how many times I've installed these tools, and every single time I forget to run the installer's root the first time. Every time. All right, so we're gonna click through these screens real quick since I've already explained these. Provide my Xilinx login again. Okay, so now you'll see we no longer have this error that there's no permissions. Oh, it looks like the installer's actually telling us the exact download size and free disk space required. Oh, looks like 2021.1 actually needs a lot more than I would have thought. So it looks like download size will be 44 gigs. The disk space required it's mentioning here is just during installation, but once the Xilinx tools are actually installed and you're running them, looks like they'll only use 82 gigs versus 175. And the disk space I currently have available, I have 433. So I'm good. So let's click next. And just another little recap of everything I'm installing and install. Oh, okay, that scared me for a second. It said it was gonna take 106 hours, but that quickly came down, it's coming down, which you'll see that time estimate. Like I said, if you have a slow internet connection, that's why I mentioned you probably don't wanna use the self-extracting web installer, but we're back down. Looks like it's estimating 2 hours right now. Oh, it's going down to 1 something, but think probably gonna step away for a second and wait for this to download. Let's skip to being downloaded. So as you can see, some time has passed. When it was all said and done, it took about 1 hour and 20 minutes. And our Vitis install is finally done. So if you'll take a look, so installation completed successfully. There's another installation script we'd have to run if we were using the Versal ACAP tools, which we're not, so I'm just gonna click OK and skip that for now. So you can see our Xilinx Information Center's popped up here, letting me know I've got all sorts of updates I could run, but I am good to go there. Just gonna minimize everything and go back to, so to actually let's test out and launch Vivado for the first time, make sure everything installed correctly. So we're going to source the Xilinx toolset, so source Xilinx, and we want to launch Vivado 2021.1 and the settings script for that, so settings.sh. So we source that and then pass the command Vivado. Give that a moment.
A few moments later.
Woohoo! So we are launched. And as you can see, it's pulling up my recent projects, but I'm not gonna open any of those because they're in older versions of Vivado. We will exit the application. And like I mentioned, if you want to install Linux, you would just go ahead and run that installer again. So let's go ahead and do that real quick. And I'm probably not going to wait the entire time for this to download again. I don't need Linux right now, but just to show you where to go back to. So we're running the installer one more time. I'm sure this takes a lot longer to launch when I'm just sitting here staring at it. I feel like Michael Scott when he launches PowerPoint and it's downloading for the first time. And I'm just telling you that I'm sitting here watching it downloading. Okay, so we're back into the installer. So we're just gonna click through the screens again, provide my Xilinx login here. So we're back to our selection list of things. So I would simply click Linux and next. And then it looks like here, it lets you select your target platform. So if you just wanted a subset of target platforms to develop embedded Linux images for instance, if you just wanted the ARM and to save space on your computer, and you're only gonna be doing embedded Linux images for ARM core chips, such as the Zing 7000, you could choose to only install Linux targeted for the ARM, or just for the microblaze. And it looks like they have about every combination possible. I recommend probably selecting Linux all platforms. Next, and of course, all of the agree options, next. And then as you can see, I'm back here letting me know I'm gonna install it in the Xilinx tools directory again, download size, full disk required. Looks like this is only a couple gigs. I'm gonna skip this for now, but you would just click next and then finish and go through the same waiting screens you did again. You don't need to watch me do that on camera. You can do it yourself from here on out. But that's all for this video. So you now have Vivado and Vitis installed on your computer and Linux when you actually click through the rest of the screens. But that's pretty uneventful. So stay tuned for the next video in the series where I'm gonna walk through how to create a base Vivado project for the RDZ7 from Digilent. Bye.